Hey y'all, welcome back to the HackShack. Today we've got another box from the folks at Hackerboxes.
This is Hackerbox 116, and the name is
Risk is good.
Let's get this on the bench and see what we have inside here. This is a set of 110 preformed breadboard jumpers. This is the Spacewalker SAO. This is the Guy Fawkes Hack the Planet SAO. Oh, nice on the back there. This is the Nexus 1 Bithead SAO. And check out the Risk is Good metallic glitter sticker. That's pretty sweet. This looks like some of the miscellaneous parts for the SAOs. We've got some LEDs and headers and stuff there. This is a 10K potentiometer. And this is a little mini lanyard for the mini game console. And here we've got some surface mount push buttons. And this is a little battery holder for the mini game console. And this looks like a little speaker for the game console. And this is a little slide switch kind of for the on-off for the mini game console. And here we've got 3 of our SOP8 CH32V003J4M6 RISC-V microcontrollers. And here's 3 breakout PCBs that go along with those. I think this is the 128 by 64 pixel OLED display for the mini game console. This is a 8 pixel addressable RGB LED module. And this is the WCH Link-E Mini RISC-V Programmer Debugger Board. And this looks like a bunch of header pins. It's like a set of female DuPont jumper wires. This is the CH32V003F4P6 RISC-V development board. This is the actual board for the mini game console. And if you look here, you can see a nice silk screen there. And if you notice, it's already got the CPU soldered on the board for us. This is a black 170 point solderless breadboard. This is the exclusive 6-in-1 Hackerboxes pen tool. Pretty neat. Got a little ruler there, a level, works as a pen. And I believe when you unscrew this end where the eraser or whatever you're going to call it is, it's got some little screwdriver tips there. So that's pretty handy. So as part of this Hackerbox, you would get a random surprise power badge. Now in this case, I've got this galactic power badge you see me unboxing here and all the little things that go along with it. I actually already have one of these from last year, so I think I'm going to hold on to it and keep it to give as a gift to someone or possibly trade for something else at some point. So I will not be putting this one together, but I will probably show you some clips from where I put it together before. And last but not least, we've got our Hackerbox 116 collectible reference card. With some information there for the development board and programming board. On the back here, we've got some pinout information for this RISC-V processor. Just like they always do, the folks from Hackerboxes have included a great set of instructions here available on Instructables. I have a link to that in the description. Even if you don't have the Hackerbox, you might find it pretty handy. All right, the first thing the Instructable tells us to do is connect up the USB-C port of the WCH Link-E module to your PC. It says the red power LED will come on. The blue mode LED next to that should be off, and that indicates that you're in RISC-V mode. If the blue mode LED is illuminated, that indicates ARM mode, which is not what you want to have going on. To toggle between them, take the cable out and reinsert it while holding down the Mode S button. Powering up the WCH Link-E module while holding the Mode S button will toggle between RISC-V and ARM mode. Again, we want RISC-V mode. Okay, next the Instructable tells us to plug in the USB-C port of the development board. And the green power LED should illuminate, and that's our good first basic test. After that, you want to disconnect the USB-C, and we'll get to work on putting these headers on. You'll see here that I make use of the breadboard when soldering the pins into the development board. And the Instructable says the longer rows of pins are going to go to the bottom of the board, pointing down. And you're going to have 3 pins on the short end, and those should be pointing up. Next, the Instructable tells us to connect the programmer to the development board. And we're going to make sure that both of these are disconnected from USB power. And we're going to use 3 female-female jumper wires to connect the ground, 3-volt, and SWD pins between the two. And ground goes to G, 3V3 goes to V, and SWD goes to SWD. Then when we're done with that, we're going to connect USB to only the programming module, which should cause the red power LED to light up, while the blue mode LED should still be off. The development board should also be lit because it's now getting power from the programmer. Next, we're going to follow a link from the Instructable that takes us to this repository, and it's going to have a URL you can see here. We're going to copy that URL, and then we're going to head back over into Arduino. And then we're going to go to File, Preferences. And if you look here at the bottom, it says Additional Board Manager URLs. We're going to pop that URL into there and hit OK. Next, we're going to go to Tools, Board Manager, and we're going to search for CH here. And see right here, we got CH32 MCU EDT boards. And I'm going to hit Install. Next, we're going to follow the link in the Instructable to the CH32_hello sketch. We're going to grab that, download it, open it up. We're going to go to Tools, Board, CH32 MCU EDT boards, and we're going to pick CH32V00X. I didn't catch it, but I selected my COM port as 33 and went ahead and hit the button to compile and send it to the board. And if you look here though, it did not want to send it okay. So I looked in Device Manager on this Windows Bench PC and I saw the 33, but I also saw this WCH thing up here, and it looked like maybe I needed to try a different driver for it possibly. After Googling around a little bit, I headed over to the WCH.cn website and grabbed this WCH link utility zip file and opened it up. Within that zip file, I found a driver looking subdirectory and found this and ran it, and basically, Windows popped up, but I said run it anyway. If you do that, your mileage may vary and I'm not responsible for what may happen. That got through running. And back in Device Manager, I still had that USB serial device on 33. I didn't have the device with the exclamation point like I did before. So this time I went back in Arduino, still with COM port 33 being my destination, and pushed things to it. And you can see this time it worked just fine. Next, the Instructable tells us to confirm the Hello World UART output. And it says we can do that by removing the SWD wire between the two modules, which I actually did not do, you'll see. And it says use a wire to connect the TX pin, and you'll see that's a different pin there. And I'm going to connect that back to the RxD pin of the WCH Link E programming board. Then I'm going to go back into the Arduino software, and we're going to go to Serial Monitor. I'm going to make sure my speed's set to 9600, and we should see a bunch of hello worlds scrolling by. And it looks like we are seeing those, so that means we are good to go. We've just shown that we can program our RISC development board. Next, the Instructable wants us to use our little breakout board with the 8-pin RISC chip. We're going to break off 2 separate 4-pin header sections here. And you'll see I'm going to stick those into the breadboard spaced appropriately for the little breakout board to fit on there. And after I do that and get it in place, I'm going to solder those 8 pins in place, and then I'll solder the MCU chip onto it. Now, I will say, maybe it makes sense, like the Instructable tells you to do, to solder the chip on first and then do the header pins. You can do what makes sense to you. And this definitely was not my second attempt where I had gone too fast, not paid attention, and soldered it to the other side of the doggone board to begin with. Next, the Instructable tells us to take a 4-pin piece of header and stick that onto the input side of our RGB strip that we've got here. And if you notice there, I'm doing a great job of soldering it onto the output side. So after realizing that, then I'm going to go back and put some pins on the input side. I guess I'm ready to chain this to something else, should the opportunity arise. The Instructable next shows us a schematic we're to build out on our breadboard. And if you're not familiar with how a breadboard works, it looks like this. The little horizontal lines are all linked together, but there's not a connection across the divide in the middle. So based on that, I'm going to just fly through here and get things connected up the best way I can. You might do it different, but as long as the end result is something that's connected like that schematic shows, that's the main thing you're shooting for. So in the next section of the Instructable, I actually read ahead a little bit, and it was going to tell us to get this WCH link utility. And if you remember, I had actually gotten a zip file that had that and some drivers and stuff in it earlier when I was trying to get that first code to push. So I actually already had that handy. But if you didn't need it this far in your journey, the link is in the Instructable. And the link is also in the Instructable to grab this fire.hex binary file. So we follow that link and get that file. So back over in the link utility, we are told to hit the icon that is for connect to WCH link. And when I connected that, it asked about updating the firmware. So I just said yes. And you can see there, it says succeed, connected, RISC-V, module. So I'm assuming it's connected. Next, we're told to hit the button that says query chip. And that should say operation result should now succeed. But if you look, I've got the chip type wrong, so I'm going to need to use this drop down and make sure I've got the right chip selected. I finally realized what my issue is and use this drop down to select the V003 chip. Now when I hit this, it says operation results got the check mark, so then I know we're good. And then I hit the query chip icon and you'll see it fills out the information there at the top right. And then the Instructable says we should go open up the fire.hex file we downloaded and then select target and program, and that should push the code to the MCU. Again, this was on Windows, but the Instructable does cover and have links to alternative to get code over to your MCU. When giving things another look over, I found one little bridge here, so I kind of broke that solder bridge and then gave it a test. And as you can see here, I think it's working as expected. We are getting some different intensity and levels of things when we move our potentiometer up and down. Pretty cool little demo there. Next thing we're going to put together is the mini game console. And first thing I'm going to do there is put that switch on. Then I'm going to preload these pads and use the little dot on this speaker and make it line up with the silk screen on the board, and tacked it into place. Preloaded one little edge of all these button positions. I did my thing where I kind of let them fall into place and then tacked the other corners down, and did that for every button. After that, I flipped it over and put the coin cell holder on the back. Preloaded the one pad there, got it in, then did the other. Pretty quick and easy for that. Next, this little set of 3 header pins for the programming interface goes in. Pretty straightforward there. The last thing that goes in is this little display, and it already hit the headers on there. So just put it through like so. I positioned a little bit of blue tack under the edge there to kind of hold it mostly level, so it would kind of be in the right position when I soldered it into place. And you can see here, I'm heating it up a little bit and pressing it down to make sure I get this all the way flush. Then I did the other pins a little bit to hold them and cleaned them up the rest of the way in this position. Next, the Instructable advises us to go over to the software folder on the main project repo. And you can see when we dig around in here a little bit, there are a bunch of different little ones we can try to mess with. So in each one of those, you can go into the bin folder, and we want to grab the hex file for the ones that you want to try. So I go in there and then I just grab and download the raw file. And I did that for a few different ones. You want to connect your WCH programming board to this mini game console, just like we did with the other stuff. You want to make sure that you've got it connected up just like this. Your ground, 3v3, and SWD pins from the programming module go to G, V, and DIO on the MIDI console. And once you get them connected up, it's going to be pretty straightforward. Just going to open firmware and hit the program thing here, just like we did in the previous steps. And that's going to push your game to the device. And you can do that for all the different ones. You can even do this verify if you want, so it can kind of make sure that it's got burned okay. Next, all you need to do is pop one of these coin cell batteries out of the packaging and into the back of the mini game console and turn it on and give it a go. Now I will say, I played with this a pretty good bit, but one thing I observed, and I thought I maybe had some kind of problem with my assembly here, but it seems to be pretty decent at eating up these little cheaper coin cells. Some of these coin cells that might blink an LED in a badge for quite a while, I don't think they're long for this world when you've got them running in this thing. Like I could start up with a fresh battery and the gameplay would be fine. And after not that long at all, it would start acting kind of glitchy. And the glitches went away when a fresh battery was put in. So that's the only thing I can attribute that to. So what do you all think about that? Any of you all that have already built this, did you find that the same? I haven't had a chance to try with like a little bit higher quality Energizer coin cell or anything like that yet, so I'm not 100% sure. And here's what it would start doing when it was getting a little glitchy. The next section of the Instructable says, does it badge? And then it also says it sure does. And so what we do is take this string loop on the keychain and we go through one of the corner holes and then loop it back around so it's secure. And then when you get that, you can just hook that itself to like a lanyard or stick it on, an existing badge or something for a conference badge, and it makes a neat little add-on. All right, now it's time to check out some SAOs. If you're new to this whole thing, SAO stands for the add-on, or more politically correct, supplemental add-on. It started as a tongue-in-cheek name, but over time it became an actual standard. There's a common connector and pinout that most people stick to, so these little boards can plug into a lot of different badges and hosts. SAOs are a big part of what folks call badge life, this amazing DIY world of electronic conference badges and add-ons. People trade them, hack them, and sometimes spend way more time on them than the actual conference talks. If you've never seen this Hackaday mini doc about badge life, it's worth checking out. I recently had the opportunity to have a post-DEF CON 33 chat with Joe from Hackerboxes. He had a few things to say about badge life and SAOs. Let's check it out.
I love badge life because it's one of these areas where creativity and technology crossover, and I just think that's amazing. I love the things that we've done with both indie badges and then also SAOs, which is just a sign up on. So it's a little thing that plugs onto a header on the board, is because initially it was just very, very simple. And it was kind of a standard, but it was like, how much current does it draw? I don't know. How big can the thing be? About 50 millimeters. Like it was just whatever. And then, the next year they made a little better of a standard, and SAOs are this fun thing that people make little badges that plug onto your badge. And so for the last electronic badge from 2 years ago was the little cat that was also a Game Boy. It had an SAO port on top, so you could plug an SAO onto it. There have been a handful of official badges, maybe just a couple, 2 or 3 of the official DEF CON badges that have had SAO ports, but many of the indie badges, many of them, and now it's almost all. have an SAO port. So if you get an SAO, you can plug it on there.
All right, now it's time to check out the SAOs that came in this Hackerbox. The Instructable made some recommendations about what LEDs to use with each SAO, so I'm just going to kind of stick with that. And they're pretty simple. These are just going to have the LEDs and then the connector. And the LEDs, you're going to have a short leg and a long leg. And usually there's an indicator on the back of the PCB about what goes to what. But that'll be from the perspective of it coming in from the front. With that knowledge, you can just plow ahead and knock these things out. So next up, the Instructable tells us to assemble our mystery SAO power badge. Now, like I mentioned in the intro, the one that was included in my Hackerbox, which was randomly selected, was the Galactic power badge. Now, I already had one of those and did that last year, so I didn't want to do another one, and I'm going to keep that one to trade. But I did assemble this one in the Hackerbox 104 video. I'm going to put a link here to that, so feel free to go back and check that out. Now, what I am going to show is I did build one of these totem extenders. Last year, one of my extenders got goofed up getting out of a cab going to the High Roller Con. So I've been needing to either fix that or get another one. So I've got a few extras anyway. I'm going to use them to kind of display and hang up some different SAOs that I like. The assembly is pretty straightforward. I think you can follow along. Whoops. Well, let's try that again. There we go. And that's working as expected. These SAOs are pretty darn neat. This totem's kind of handy. I think it's a nice little thing to have around if you're into this stuff. I will say, be careful when you are first connecting and disconnecting these things. The connections will be kind of tight, so just kind of give it a little bit of wiggle. Don't go ham on it out of the gate, or you may rip the connections right off your SAO. Now, while I had this totem out and working, I decided to try a couple of SAOs I got last year. These are from Make It Hackin'. He makes some great SAOs. This one is the tricorder one he has. It's really neat. Now, I really love this one right here. This is an SAO, and it was just the board only. They didn't have the parts. I got it last year from the Aerospace Village. And then, of course, it's of the Winnebago from Spaceballs. And, you know, I have a special affinity for that if you saw the intro to the Hackerbox 104 video last year. And these others are related to our good friend COVID-19. And he has, you know, an option if you went to Hacker Summer Camp and got it, or if you didn't get it. As the Instructable starts to wrap up, it's got a reference here and tells you to go check out this BBS video from the folks at the Serial Port. And I highly recommend going and subscribing to the folks at Serial Port. They are putting out some great content. And they also recently put out a video about IRC, which is also near and dear to my heart and probably many of you out there. And there's also a little scroll down here and it mentions the BBS documentary, which I also highly recommend. It is fantastic.
It looks like we're going to have ourselves another giveaway. The nice folks at Hackerboxes have graciously offered to send a
Hackerbox 116
to a randomly picked commenter. We'll be picking the comment on
September 14th, 2025.
And remember, Hackerboxes only ships to US addresses for this giveaway. So if your comment's picked, but you don't have a US shipping address that we can use, we'll need to pick someone else. Good luck.
At the time of this recording, there's still Hackerbox 116s in stock.
If you don't win the giveaway and want to get one, check them out. Or go ahead and subscribe.
Right before the line, "Risk is good," is said in the movie Hackers, Angelina Jolie's character said, "Risk architecture is going to change everything." And this Wired article from March of this year says that she was right. What do you think?
Hey, if you made it this far, thanks for watching. Hope to see you again next time. Take care. Bye-bye.